Okay, so let's open up a new model. Bring in my smooth step position block. Create a demux. Add the third port. Oops. Let's do it the old-fashioned way. Just set it equal to 3. Hit run from the scope. All right, and we see a bit of a resolution issue there. So from configuration parameters, I'll adjust the solver. Oops, solver there, and we'll put a max limit on the time step of 0.01. And you'll see that'll make it much smoother. All right, and I think it's useful to look at each of those in their own display. So we'll set up 3 displays for each. And again, let's do this. All right, so there's your smooth step. That's the top one. And basically, the second display shows the derivative of the first, which we know to be velocity. But this is how position changes with regard to time. And of course, the third one would be acceleration. We'll take a peek at how we did this. And I took a look at this, thought about it over the last couple of days, and realized it's not exactly obvious, but I will point to the use of the sine function right now. And based on this kind of anticipation, I'll kind of show you how we did it. All right, so let's go to get. Oh, and I want to give some credit to one of my best buddies. His name's Paul Mitige. He teaches dynamics at Stanford, and he's been really, really good at mechanical dynamics for a long time. And he explained this idea to me, so I like the idea a lot. So thank you, Paul. All right, so here's a sine function. Let's scope it. Okay, and I want to focus on a window of 1 second, and so I'm going to go into the sine function, and I've been doing this for a while, and I just kind of know you can do that by setting the frequency equal to 2 pi. And again, let's set the window right here. 1. Okay, you might see it already, but I'm going to do a little bit of work to really make it clear. It's this idea of looking at that middle portion of the sine curve that we see as smooth transition. So we're going to use that. And I kind of like going up, and so I'm going to begin by just changing the amplitude. I'll make it -1. Okay. So again, it's now going up. All right. And let's just kind of set up the rest of it. All right. And so here's how I'm going to do it. Actually, again, let's view it all. I need to get rid of all this stuff at the beginning, and I need to get rid of all this stuff at the end. And so we're going to do that with a switch. And so user-defined functions, no, signal routing, and let's get the switch. All right, and we're going to just kind of set up the condition based on time, and basically we want this to be the value when the simulation time generated by the clock function is greater than 0.25 seconds. And we're going to do a second fix in a second, but I don't think you really see it until I do this. So we want to start off at 0. So this will be the condition until 0.25 seconds. So let's run it again. All right, and this is where I really wanted to make sure you saw why we're going to essentially move the whole curve up. And so that's part of the definition of the sine source, and it's called the bias. And we're going to put in a 1, but actually, you know what we're going to do? We're going to put in a 0.5. And I'm going to basically try to kill two birds with one stone. And hopefully this is not too confusing, but I think you'll see that we're going to end up at a good place. All right. And so what I did was I changed the amplitude to be half that value, and therefore the bias needed was only half as well. All right. So that's looking really good. That's what I want. I want to go from a horizontal kind of value. This is where we are at 0.25 seconds. We start ramping up. And so now we just got to finish it and keep it at that value at the peak of the sine curve. All right. And so we'll do the same trick with another switch. And this time, the output of this is what I'll call the false condition. And so the threshold where the switch takes place will be at 0.75 seconds. And this time the true condition will be the constant, but a constant with a value of 1. All right, so that works pretty good, and I'd say my validation, maybe the validation is really that I did this right, but let's go ahead and do the comparison. And this kind of shows why do you need a block like this so that you can rapidly parameterize it. All right, so our ramp start time is 0.25 seconds. Our period of transition is 0.5, which is what I already have. And this time we'll go from 0 to 1. Right, so we're just taking that first signal. Looks pretty good. Thanks for watching.